We're still solving trigonometric equations, but the difference today is they're going to be a little bit more interesting, or maybe we'll have to use some identities or maybe some other algebraic techniques in order to solve them. So if you'll notice in this first example, there's both a sine expression and a cosine expression, which would make it very hard to get either sine or cosine by themselves, like we were doing yesterday. So what we need to do first is try to rewrite one of those in terms of the other. Now I know that I see that one of those expressions is a sine squared, and I know that we have this identity, sine squared of x plus cosine squared of x is equal to 1. So what I could do is I could solve this equation for sine squared by subtracting cosine squared from each side. And that would then give me an expression that I can put in place of sine squared in this equation. Now let's see what happens if we do that. Alrighty, so now in my equation, the only trig expression that I have anywhere is a cosine expression. So that'll make it a little bit easier to solve. So I'm going to go ahead and get rid of the parentheses here by distributing that 2. And now I notice that I've got both a cosine squared and a cosine. So that means this one's going to behave like a quadratic function, even though it has these transcendental functions in it. So in order to solve with a quadratic, typically our strategy is to create a 0 on one side of the equation, and then we'll try factoring. And if factoring doesn't work, we do have some other tools under our belt for quadratics, but factoring is by and large the easiest of them all. So I'm going to try that first. So let's see. I think first things first, here on the left side, I'm going to add together the two constants. So that would give me -2 cosine squared of x, and then I'm adding this 2 and this 3, so that would be plus 5. And now the expression that's squared presently has a negative coefficient, so I think I want to make my 0 here on the left side of my equation. So I'm going to do that by adding 2 cosine squared to both sides. So that would give me a +2 cosine squared of x on the right. I'm going to subtract 5 from both sides. When I do that, both of the 5's disappear. And then on the right side, I already had a plus cosine of x. So now in order to solve this expression, I need to factor. Now there are only 2 terms there, and both of them have a cosine of x in them. So that means they have a cosine of x in common factor, cosine of x. If I factor out a cosine of x, that would give me 2 cosine of x plus 1. Now that I have it factored and equal to 0, I can set each of the factors equal to 0 separately and solve them. It says cosine of x is equal to 0, and 2 cosine of x plus 1 is equal to 0. And that gives me 2 of the more simple equations like the ones we were solving yesterday. Now cosine of x equals 0 is as simple as it's going to be, so I'm going to go straight from there to finding the angles. The angles that would give me 0 for cosine on one trip around the unit circle between 0 and 2 pi would be pi over 2. My stylus is lagging. Pi over 2 and 3 pi over 2. And for the other one, the 2 cosine of x plus 1 equals 0, I have to first solve it for cosine of x. So I would do that by subtracting 1 and then dividing by 2. So now I need the angles for which the x value on the unit circle is a -1/2. The x value is negative in quadrants 2 and 3. And the reference angle for cosine to be 1/2 would be pi over 3. So in quadrant 2, that would be 2 pi over 3. And in quadrant 3, that would be 4 pi over 3. So my solutions to this one, I have 4 of them. I've got these two and these two. I want to list them in order from least to greatest. And the easiest way to get them in order, in my opinion, is just to kind of go around the unit circle and see which one you get to first. So if I start at 0 and I start moving counterclockwise, the first of these 4 angles that I would get to is pi over 2. So I'd write that one down first. Next, I would be in quadrant 2, so 2 pi over 3 would be next. Next would be in quadrant 3, so 4 pi over 3. And then the last would be 3 pi over 2. That's the negative y-axis there. Okay, so that would be what I would list as my solutions. All right, now you're going to try this one and answer on the Google form.